So in the second part of section 2, we're going to talk about how to solve quadratics by completing the square. So completing the square is a method we can use when we don't have a quadratic that can be factored. We can also use it if it can be factored, but it's an alternative to solving a quadratic when it's not able to be factored. So first we're going to review a perfect square trinomial. So a perfect square trinomial is when you factor it and you get the same number in both sets of parentheses. So I get like x plus a times x plus a, which we write as x plus a squared. So when we have the same number in both sets of parentheses with x, and we can write it as being squared. So when we do completing the square, unlike with factoring, when you want it to be equal to 0, with completing the square, we want it to be equal to the constant. So we want to, if we're basing off of standard form, ax squared plus bx plus c, we want to move that c to the other side. So the x is around one side, and the constant is on the other. The next thing we have to do is to make sure a is 1. So the number in front of our squared variable has to be 1. And if it's not, the first thing we're going to do is divide everything by that number. The third step is to make that left side a perfect square trinomial. And the way we do that is by adding b divided by 2 squared to both sides of the equation. Now this b may be different than it started off with depending on whether or not you had to divide by a. Okay? The left side is going to factor as a perfect square trinomial specifically into x plus b over 2 and then squared. And then the last step is to solve by taking the square root of both sides. So it can be a little bit difficult to understand how to do completing the squared based on these steps. So I am going to show you some examples so you can see how it works. So our first quadratic is x squared plus 2x minus 35 equals 0. So my first step is going to be to move the 35 to the other side. So we're going to move our constant. So we're going to have x squared plus 2x, and then I'm actually going to leave some room here for when I get my perfect square, equals 35 plus whatever that value is. Okay. Now I'm checking the a is 1, which it is, and I'm going to do my b divided by 2 squared. So b is the number in front of x, so I'm going to do 2 divided by 2, and I'm going to square it. 2 divided by 2 is 1, so we square 1 and we get 1. So I'm going to add 1 to both sides. Now I want to factor my left side, x squared plus 2x plus 1. And it's a perfect square trinomial, and it's always going to factor as x and then whatever b divided by 2 is. And 2 divided by 2 is 1. So x plus 1 squared equals, now 35 plus 1 is going to be 36. The next step is to take the square root of both sides. So when we take the square root of a square, they're going to cancel. So my left side is going to become x plus 1 equals. Now this is where we're going to go back to when we were first talking about square roots. So the principal square root of 36, or the one that we typically think of, is 6. However, if we remember back to what happens when you square a negative number in parentheses, 6 squared is 36, but negative 6 squared is also positive 36. So I'm actually going to have plus or minus 6 here, because if I square 6 or negative 6, I'm going to get a positive 36. Okay, so now I have x plus 1 equals plus or minus 6, and my final step is to solve for x. So I'm going to have x plus 1 equals 6, and I have x plus 1 equals negative 6. So we're going to subtract 1, and we get x equals 5. And then I'm going to subtract 1 again, and I get x equals negative 7. Now this is one of those cases where I could have used factoring to solve this quadratic, since I got two rational numbers as solutions, but that's not always going to be the case. So for example, our second example, x squared plus 8x plus 10 equals 0. That's not factorable. The only way to multiply to 10 is 10 and 1 and 5 and 2, and neither of those are going to add to 8, so I can't use factoring to solve this. So I'm going to follow my steps. So the first step is going to be to subtract 10 from both sides. We get x squared plus 8x, and I'm going to leave room, equals negative 10 plus, leave my room. Now we're going to do b divided by 2 squared, so 8 divided by 2 squared. 8 divided by 2 is 4. 4 squared is 16. So we're going to add 16 to both sides. Now my factoring, I'm going to have x and then plus b divided by 2, which was 4. So plus 4 squared equals negative 10 plus 16 is 6. So we take the square root of both sides, and the square root and the square cancel on the left. So we get x plus 4 equals plus or minus. Now I can't take the square root of 6. It's not a whole number, so we're going to leave it as square root 6. So now my last step is a little bit different from my previous example. So since I'm not equal to a whole number, what I'm going to do is I'm going to go ahead and subtract 4. So we get x equals, and I'm going to go ahead and put that negative 4 in front of the plus or minus. So we're going to get negative 4 plus or minus the square root of 6. Now I can technically write that as two separate answers. I don't have to. So I could write it as x equals negative 4 plus the square root of 6. And I can write it as x equals negative 4 minus the square root of 6. But I don't have to write the two separate answers. The plus or minus lets me know that I'm doing a plus and a minus. It's also important that you don't subtract 4 from the square root of 6, because 4 is not underneath a square root, so I can't subtract it from the square root of 6. Next we have x squared equals negative 6x minus 10. So my first step is I want to make sure all of the x's are on the same side. So I'm actually, instead of moving a constant, going to add 6x to both sides. So we're going to get x squared plus 6x, I'll leave some space, equals negative 10, leave room. Okay, so my b is 6, so we're going to do 6 divided by 2 squared, which is going to be 3 squared, which is 9. Add 9 to both sides. When I factor my left side, we're going to get x plus 3 squared equals, and then negative 10 plus 9 is negative 1. Take the square root of both sides. The left side becomes x plus 3 equals plus or minus. Now the square root of negative 1. I can't take square roots of negative numbers, but the nice thing is in section 1 we introduced that concept of I, because we know I is equal to the square root of negative 1. So then I'm going to have I. And then just like our last example, I'm going to move the 3 over. So I'm going to subtract 3, and I'm going to get x equals negative 3 plus or minus I. All right, so the last example we're going to look at an example where the number in front of x squared is a number other than 1. So we have 4x squared minus 2x minus 5 equals 0. So my first step is going to be to add 5 to both sides. We're going to get 4x squared minus 2x equals 5. Now I have to, because a isn't 1, I have to divide everything by 4. So we get x squared minus 1/2 x. Now is when I'm going to leave my little room, equals 5/4 plus, and I'm going to leave my space. So now when I b divided by 2, b is negative 1/2. So I'm doing negative 1/2 divided by 2 squared. Negative 1/2 divided by 2 is negative 1/4. I'm going to square it, and I'm going to get positive 1/16. Which I'm going to add to both sides. When I do my factoring, it's going to be x. Now this time, we have negative 1/2 divided by 2. So instead of it being a plus, it's going to be minus 1/4 in my parentheses squared equals 5/4 plus 1/16 is going to be 21/16. Okay. And the reason why I'm leaving it as fractions is because my next step is to take the square root. And it's easier to take the square root of a fraction than it is to take the square root of a decimal. So when I take the square root of both sides, I'm going to get x minus 1/4 equals plus or minus. Now I can't take the square root of 21, so it stays square root 21, but I can take the square root of 16, which is 4. Then my last step is to add 1/4 to both sides. And we're going to get x equals 1/4 plus or minus square root 21 all over 4. We are not going to do a lot of examples where the number in front of x squared is something other than 1, because as we can see by this example, it can potentially lead to us having fractions, and fractions are just not fun to deal with, especially when you're trying to solve a quadratic. So this last question here that we have, which is, when does completing the square work well? When does it work not so well? Well, completing the square works well when a equals 1. So as long as a is 1, completing the square is not too terrible. It is more steps than factoring, but you don't have to worry about dividing and dealing with fractions. So it doesn't work well when a is greater than 1. Because if your number in front of x and your constant aren't divisible by a, like in our last example, then we end up with fractions. And nobody wants to solve a quadratic by completing the square that's going to have fractions. Let me know if you have any questions about solving quadratics using completing the square.